Hi everyone. I am Charlotte Sennersten. I'm a computer scientist from Sweden, from Kristianstad University. And will today present this topic that me and my colleague have written up and provided to this conference. So the topic of our article is optimizing triple parallel demonstration. Forgive me for this and for the name. I will explain further on during the presentation what this means in AI, artificial intelligence and machine learning education, and agentic approach to integrated scientific reasoning. And before I continue, I will just give you some context. So I'm teaching several courses at our university, at the, and especially AI courses and research methodology courses. And there are some challenges in doing so for our computer science students. And that's why we have chosen to raise this. So this is what I will go through during this presentation. So the outline is article focus, just briefly, and the context, and then education 4.0, what does this mean and where are we going, where are we all? And this is not just for us at Kristianstad University, this is more so an international context. Educational challenges, as we have heard from the previous speakers, that how we solve this all together, bottom up and top down. And then how to optimize learning and relational dependencies. As we know, AI is all about dependencies or relationships. And this becomes the problem for us. And so, and then thanks to the reviewers for this conference, pointed out UNESCO's role and guidelines here as AI competency framework that we can lean on or at least spring from. And later implementation as an AI agent architecture persists a conceptual paper. This is not it is presented to teach and to reflect during that teaching and what we are lacking, but this is not a full study. So I just want to say that as the first off. And then the problem here is that we have several streams at the same time for students, and we're going to interpret those streams and kind of secure that the learning and understanding of these streams in parallel are learned. And I come to that. And this is where this triple demonstration framework is coming into play. And that's our references on future work. Where are we heading from here? So just as starting off, I take this directly from the article, and if you are keen on reading about this and maybe see that this maybe can be useful and maybe spring from, it is proposing a conceptual triple parallel demonstration framework. And why this is in research methodology courses that I teach with computer science students, is that we have to go through empirical investigative studies, the empirical part. How do we do this scientifically, empirically? And in our theses later on, we also have to have software architecture. We need to have an implementation. So we have an empirical take on it, and we have to implement for it and getting a result at the end. And this can be somewhat difficult for some students, and also to reflect in the write-up how all these shall hang together. Even if we go through this, it's quite much to penetrate through for a student. So do we have the tools in our situation as teachers? I would not say we have been mentioning Canvas here. Well, that's quite good as a source, but it's far from, helping us fully. And there are other tools as well, but it would be very useful if we had some kind of platform that we could use collectively, and all, not just single at one university here and one university there, but actually we say collectively all together. Now sorry for this slide. So this is the course I'm teaching, and this is why I exemplify with and with. So this is a research methodology course, and you see these dots. I didn't say 100 students. These are single students as a single dot. So you can see them as a network, as a graph, or anything. So they are learning points. And here we are, you know, as a single tutor, instructor, to reach all these nodes at once. That's why I put it on as dots. And so we come then to education 4.0, and in the overall umbrella we are all under is that we have not just education 4.0, industry 5.0, 4.0, 5.0, 6.0. We have the telecommunication, 4G, 5G, 6G. I can just continue on that. I stop there. But that's where the reality we are under, and this is where we push out our students. We push them out into this reality. So in terms of education 4.0, you see I have underlined at the bottom here. And also back to the keynote speaker, I want to thank you that you kind of laid the path for me as well and for all of us to see, you know, the progression over time and see here that going from 1.0 up to 4.0, we are now intelligent adaptive learning. And as we know, AI has been mentioned several times here, personalization and complex skills. And with AI, we connect the dots and we fuse the data. And how do we track and trace all these relationships? That's the challenge for us. And it's easily so as an instructor teacher to be burned out. So it doesn't happen, and we don't just lean on these tools. We have to evaluate what is the outcome of it. And we stand there and we try to do the best we can with our best ability. So what is the challenge here then? Well, the educational challenge in artificial intelligence and machine learning as to what I am standing in and where I teach and I work with the students around and with is increasing complexity we are standing and we are facing. Now you see here, the second line here, current teaching often sequential and fragmented. So if you see, our courses are laying a foundation for our students. Now the problem with this, if I say conservative, old-fashioned view, is that we have course. It is for the student to bind these things together. When we have AI, this becomes a different space. We have that fragmentation, sequentially learning as like you're turning a page in a book. You turn page. But in AI, it just comes all at once. That's the difference. So how do we meet this? How do I, as an instructor, meet all these bombardments? And I go back now, back. My 100 nodes, I have to speak to them. I have to meet them. I have to have a dialogue with them, and all at once, to not bore them. Because now they are used to this personalization all of a sudden using ChatGPT and all other LLMs. And I have to kind of overcome, and I have to be better than this. It's sometimes, not all the time, because that would be totally exhausting. But we have some challenges here, real-time challenges in the room. And especially with people, as I for many years ago, I taught in game development, 3D game development. And also we noticed with our students, they were very, they had instant feedback. That creates a challenge in the room as well, because if you're used to instant feedback, that puts a challenge on us as standing in the room, meeting the questions and everything. So that fragmented sequential learning we have had is still there, but that is somewhat, we say, the elephant in the room as well. So the problem formulation here in this article is around how we bind together and show the relationships between mathematics, architecture, in our case, implementation, and empirical work. And now they are separate, but in the research methodology, we have it all together. And we should like to have a tool to show the relationships and how these are penetrating through. So a student actually understand if you change here, this will be the results. You actually have to change your question and you have to change your variable, your dependent or independent variable, to get this as an outcome. And so all this real-time push we have with AI as well changes this dynamic. But we don't have the tools really. We try. So the question here, how to optimize AI tutoring using triple parallel demonstration. That is what I'm in my kind of discussion with myself in front of all my students. How do I do this much better? I am not there yet, I can tell you. I try to be the best, to my best ability, but I'm not there. Now, in terms of writing this article, and thanks to the conference, I have to say, because that also pushes us as standing on the floor to actually start to reflect and share with each other, and not standing there all by ourselves. So these foundational principles guide the formation as from Trini and Karabot as one of our references, integrated AI-oriented pedagogy model. So the pedagogy around how we do this, not just the tools, but also the pedagogy in terms of doing these duality at once in real time. And now we have UNESCO, and this was also thanks to the reviewers. I want to thank the reviewers of our article very much, because in terms of standing there on the floor, UNESCO's guidelines can be of support. And I have, since the reviewers of the conference suggested this for the article, also in my AI courses to the participants in my courses, actually pointed them to this as well. So thank you very much for that. And for you that may not know what UNESCO is, it's United Nations Education and Science Organization. So this is like an umbrella for all of us internationally, where we can build a framework together. So therefore, very important. So we have a collective framework we can lean on and we can discuss with. And that is for students, and it's also, as you see, other guidelines also for here for education and research. So it's not just students, it's also education and research. I mean, students are in the education, of course, but it's a different perspective thinking. So this is just an example, and I became really happy when I saw this. So you see here, this is taken from UNESCO's guideline, and you have a progression line here that I wasn't aware of, and I was very happy to see. So you see here aspects: human-centered mindset, ethics of AI, AI foundations and applications, AI pedagogy, and AI for professional development. And then acquire, deepen, and create. So you have a kind of matrix over different steps here that are very useful as to when you are going to evaluate the AI into what you now are doing in your courses, and having this as the base is a really nice foundation. So I can say thanks again, because I did not know this. So very useful. So we come now to this, finally, a long way to Tipperary, to the triple parallel demonstration TPD model. It's not a very elegant name, I agree on that, but you know, if you have a better name, you know, tell me. So these are 3 synchronized learning streams. That's what we're talking about. With these 100 people, I just go back, I love to go back and forth. With the 100 people in the room, my students, is that I would like a tool where I can have 3 screens at once, or a shared three screen, where I can pump out empirical investigative studies and show with variables what this is, and through an implementation architecture and different architectures, how this would penetrate through and say, well, you know, if you do this, you will get that. And I don't have that, because I have a very good chance to show some parts in real time, but it's still sequential. And then we have the software architecture and data variables. in that implementation, as I said, and mathematical use and modeling. So the different models, what part do they play in this play as to what I want at the end? I want that orchestration and showing my students, this is the power of it. And there I fibble back and forth and do as best as I can. But I want some other power tool to be able to demonstrate this very more effectively than I have today. So it's a little bit of a one-man show there with my 100 nodes to be able to demonstrate this in real time. Our deans and our principals have to think about this. So the real-time integration by AI multi-agent system, why do I now say this all of a sudden? Yeah, because in my AI courses, I focus on AI agent architectures. And that is of no coincidence, because with all the AI we are talking about and the people participants I have in those courses are looking for how to deal with their data and into their organizations where they stand, and they have to solve, problems. No one else will solve for them, and the understanding they have to create for themselves to be able to progress. So they are in industry and in organizations, while I'm also, in my research methodology course, stand with my program students. So it's society and our program students at once. So it's an orchestra of, or we say, an orchestration of 200 people, where they stand and what they want and what they have, what they don't have. And that's why this article came to life. This is what it is. This is what I'm talking about. So you see here a TPD model, and 3 sub-agents architecture, and this is to be, we say, the ultimate visualization here as to show relationships at once in real time is how this penetrates through. This is a kind of good illustration, but not yet perfect. It could even be better. It is still a little bit traditional. You see that split screen or that split view at the bottom, the student interface. But that's what I'm talking about. And I don't have that for the moment. And then people say, well, Charlotte, integrate that. Yeah, we will, but it will take some time. And this article is not that, but it will come. Have to put the thoughts first into black and white and into text to be able to concretize it for yourself and others, so they understand what you're talking about, even if it can sound a little bit hocus pocus. So this is what we are aiming for, and we want, and we need this even more. And I just want to tell you, yesterday I looked at we are sitting here. The GDC conference in San Jose in California is going, and I think it ends today, actually. And Jensen Huang from India had the keynote speech there. And I listened to that this morning. And so with all what is happening on the computer science and computer front and the processors and our quantum computing and what will come, and the AI on the edge, we have a heck of a time in front of us, I would say, even on the education part. And so this is just a little fraction into a problem space, but it's bigger, as we all know, and how we tackle that all together, and how we prepare our students for a new labor market. They are going to work 10, 20 years, 30 years ahead, and we are equipping them right now to meet some of these challenges and not feel lost in the architectures. Sometimes I feel that is a big take for us, and it's a big take for them. So you see here, stream 1, we call them stream 1, stream 2, stream 3. And we have the hypothesis formulation and testing, and to have the students to be able to play around with this and actually feel like this is fun, and seeing how it penetrates through in various architectures in an implementation. And then the mathematical side, how with the different models and what I want to be done and how, depending on my infrastructure I have behind, computational wise, or what now it can be. This is where we are lacking, and I am lacking. And if you have any platform or anything, you're most welcome to tell me. So this is what we have to plow through every year, but we lack the facilities in how to do this optimally. And then there's some of the references, and it's very useful to see and go in and do look at current work and challenges and reviews currently done worldwide as to where we are. At the same time, as we have tech industry pumping and we are all users, yeah, there's some kind of glitch and gap here. And I don't feel peace with myself in this situation. I feel very restless in that. So, as I asked you, do you know any existing PPD framework in science education? And you see that this conference is New Perspectives in Science Education. So we kind of have a big take ahead of us. So the future work here is to implement, and it could possibly be a student implementation project, a minimal viable product, or what now we see this as, conducting control studies for indicating and learning outcomes, especially that, to see what differences, as now with your studies with ChatGPT, as to be using such a platform or such a framework, as to how it could contribute to your problem solving and insights more quickly. How, you know, there are lots of questions in there, and it would be very exciting to see how that would result. So I don't know if my time is up.
Oh, good on time.
I am. Thank you very much.